Hello, so now let us solve the problem. So as you see, our integrand is a rational function. A rational function is a polynomial divided by another polynomial. And here you see that the degree of the numerator is 3, the degree of the denominator is 4. So the degree of the denominator is more than the degree of the numerator. So this means that the trick we have to use for solving this integral is actually the method of partial fractions. So what we do, we actually write this given fraction as the sum of some fractions, yes? Okay, to do that, I want to factorize the polynomial in the denominator. The factorization is actually quite simple. So you see that between these three, I can factor x squared out. Then I have x squared minus 4x plus 3. But this can also be factorized one step more. So this becomes x squared, x minus 1, x minus 3. So that is the factorization that I want to write here in this denominator. Yes? So x squared, x minus 1, x minus 3. X squared, x minus 1, x minus 3. And then I write this as the sum of partial fractions. Here I have 3 factors involved, so it means that I have 3 fractions. One of them is quadratic, 2 of them are actually first degree polynomials. So for the one that I have, so in principle I have to have 3 fractions. The denominator of the first fraction is x squared, the denominator of the second fraction is x minus 1, and the other one is x minus 3. The degree of this one is 2, so we have to write the most general first degree polynomial here, and that is a times x plus b. And here we have a first degree polynomial, so we should have a constant number here, c, and another constant number here, d. Now my goal is to find a, b, c, and d. To do that, I multiply both sides by the denominator here. Yes? So I multiply everything by the denominator of this fraction. Of course, when I do that to the left hand side, the one that I multiply totally cancel this one, and what is left for me is just the numerator, which is x to the power of 3 minus 7x squared plus 7x minus 3. On the right hand side, I am also multiplying the whole right side by this expression. When I multiply this by the first fraction, x squared here in the denominator will be cancelled with the x squared part of this one that I am multiplying. So these two will remain that are supposed to be multiplied in the numerator here. So then it becomes ax plus b times x minus 1 and x minus 3 plus, okay, I will take that one and multiply it here. This time x minus 1 in the denominator and x minus 1 that I am multiplying cancel out, and these two factors are left that are supposed to be multiplied here. So then it becomes cx squared x minus 3. And for the same reason, when I multiply this by the last one, this one and that one are cancelled. This is left, which is supposed to be multiplied in the numerator. Okay, so now what I have to do, I have to expand the right hand side and write it as a standard polynomial. Standard polynomial is a polynomial that I actually arranged the x variables in descending order from the highest power of x to the lowest power, and every power of x should appear in one position. Okay, I will explain this shortly. So let me just do the multiplication. So do this one, I have to multiply these two back, but of course I will immediately get x to the power of 4, x to the power of 2 minus 4x plus 3, and then I have to multiply it once more by ax plus b. But The next two are easy. I just multiply this in here and there. The same thing I will take multiply it here and there. So then it becomes cx cubed minus 3cx squared, and then I have dx cubed minus dx squared. Okay, I have to multiply this once more, so this becomes ax cubed minus 4ax squared, and then plus 3ax. And then I have plus bx squared minus 4bx plus 3b, and then plus cx cubed minus 3cx squared plus dx cubed minus dx squared. Okay, so now you see ax cubed appears here. I have also a cubic term here. I also have a cubic term here, and that is the highest one. So what I do, I will actually factor x cubed out. I am left with a plus c plus d times x cubed. Okay, and now I go to x squared terms. So I have this one x squared, this one is x squared, this one is x squared, that one is x squared. So I have to factor x squared out. So what is left for me? Minus 4a is left from this one, b is left from this one, yes, and minus c from this one, minus d from that one. So then it becomes b, and then I have minus 3c, and then I have minus d times x squared. Yes, and then I go to first degree for x. So this is one term, this is another term, so that's it. So I have only these two terms. So I factor an x out, and I am left with 3a from this one, and minus 4b from that one times x. And finally I have a constant number here. That's it. That's the only constant number that I have. So I will write plus 3b. Now what I have to do, on the right hand side I have a polynomial of degree 3. On the left hand side I also have a polynomial of degree 3. I want to fine tune these coefficients a, b, c, and d so that this polynomial is identical to this polynomial. This cannot happen unless the corresponding coefficients match. So I reach to a system. So this means that, for example, this one, which is the coefficient of the cubic term, should match with 1, which is the coefficient of the cubic term on the left. And this one, for example, should be minus 7, this one should be 7, and this constant term should be minus 3. So I am lucky that I can start solving the equation using that. So let me just write them. So we realize by comparing the last term that 3b is supposed to be minus 3. So this immediately gives me that b is minus 1. Okay? Now that I know that b is minus 1, I go and compare this one with this one. So I will say that, okay, 3a minus 4 times b, but b is minus 1, so this becomes plus 4, is supposed to be equal to the coefficient of x here, which is 7. And you immediately realize that a is equal to 1. Okay? Now that a is equal to 1, I go one step backward here. I will take this one and equate it with minus 7. But I also have a, I have b, so I place them here. So what happens? Minus 4a becomes minus 4, plus b becomes minus 1, so it is minus 5. So it's minus 5 minus 3c minus d is supposed to be equal to minus 7. Yes? if I just simplify this a little bit, so it becomes 3c plus d is equal to 2. So that's one equation that I get here. So this is minus 5, I moved it to other side, it is minus 2, then I multiplied everything by a negative sign. Okay, there's also another coefficient that I have to compare, and this is this coefficient and 1. Okay, but I already know a, so I replace a with 1, so I have 1 plus c plus d is supposed to be equal to 1, so this means that c plus d is equal to 0. This is another equation. Okay, then what I have to do, I have to set up a new system. So let me start here. I have 3c plus d equals to 2, and I have c plus d is equal to 0. Then I have to solve this system. For example, if I subtract these two, then it means that c is equal to 1, and when c is equal to 1, d is equal to minus 1. Okay, so now every coefficient that I need is found, yes? So now if I want to integrate this fraction is exactly equal to that fraction, and I realize this fraction can be decomposed into 3 fractions with these coefficients that actually I found them here. So the integral, so let me write the question mark, so for saving some time. So the question mark is equal to the integral of the first one with a equals to 1 and b equals to minus 1. So this becomes the integral of x minus 1 over x squared dx, and then plus this integral in which c is 1. So this becomes plus integral 1 over x minus 1 dx, and finally the integral of this one where d is minus 1. So this becomes minus integral of 1 over x minus 3 dx. As simple as that. So these are famous integrals. So for example, the primitive function for this one is ln of absolute value of x minus 1, that's it. And this one is ln of absolute value of x minus 3. For this one, what we need to do, we need to separately divide them. So what I do, let me just write the answers below them. So the answer to this part is just ln of absolute value of x minus 1. And the answer to this part is ln of absolute value of x minus 3. And to do this one, I break it into 2 integrals, x over x squared minus 1 over x squared dx. So here 1x and 1x are cancelled. I get 1 over x dx, and then minus integral of 1 over x squared dx. But again, both of them are simple. The integral here is just ln of absolute value of x, and this one is simply minus, so the integral here is minus 1 over x, but I have also a minus sign, so this becomes plus 1 over x. Okay, so now if I combine everything, the question mark finally is equal to, so what do I have? I have 1 over x, I have ln of x minus 1 minus ln of x minus 3. So let me write all of them. So it's 1 over x plus ln of absolute value of x and plus ln of absolute value of x minus 1 minus ln of absolute value of x minus 3. And of course you know that we always add a constant of integration there. So that's the correct answer. But if I want to write the answer provided at the end of the book, so you know that here I have plus, here I have plus, here I have minus. So according to the formulas of ln plus ln of b is equal to ln of ab, and ln of a minus ln of b is equal to ln of a over b, I can combine all of them into just one single ln. that I multiply the numerators. So these are with positive signs, they are supposed to be multiplied, but this will go to the denominator. And then I have plus c. But of course you know that absolute value of x times absolute value of y is absolute value of xy, and absolute value of x over absolute value of y is nothing except absolute value of x over y. So if I want to use these two formulas, so finally I get this as my answer. 1 over x plus ln of one absolute value in which the numerator is x times x minus 1 and the denominator is x minus 3 plus c. And that is the final answer to this integral. Okay? One thing that I want to mention is that sometimes you can calculate these numbers a little bit easier. So for example, this is the trick sometimes I use. Not for this one, for which the denominator is a quadratic term, but this method will work for these two. For example, after I factorize this, assume that you want to find c. You ask yourself, for which value the denominator is 0? You immediately realize that x is 1. So then you go to the left hand side and drop that one from the middle, and in what is left you put x equals to 1. Okay? So let me just do that. If I put x equal to 1 everywhere else, so this one becomes minus 7, this becomes 7, they are cancelled, this becomes 1 minus 3. So remember the numerator is minus 3. But the denominator, when I put 1, it becomes 1, this becomes minus 2. So it becomes minus 2 over minus 2, which is 1. And you see this exactly, I got c is equal to 1. Let me do it once more. For example, for d, I ask myself what happens when the denominator is going to be 0. The answer is x equals to 3. You go to the other side, you take x minus 3 out, which is the denominator here, and replace x everywhere with 3. Of course, here the calculations might be a little bit harder. If I put 3 here, it becomes what? It becomes 27. If I put 3 here, it becomes minus 63, and then plus 21 minus 3. So if you add them, it becomes 48, and then it is 15 minus 18. So numerator becomes minus 18. And then if I put 3 here, it becomes 9. If I put 3 here, it becomes 2. So minus 18 over 18 is minus 1. And that is exactly d equals to minus 1. But as I told you, this method only works for the ones with the first degree. Thinking about it is not hard. I hope that you can sit down and think about it and convince yourself that is always the case. Okay. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.